In this video, we're going to start looking at integration of trig functions. We're just going to have a look at our rules, which we actually learned about when we did differentiation, and just apply them to some very basic examples. Right, so this is a table similar to what you will get given in an exam. You get given the original function and the derivative. Now, in order to integrate, we're going to go from the derivative, so that in other words our function must look like this, back to that function. And then don't forget to add the constant of integration if you're doing indefinite integrals. So let's just remind ourselves, if my function is sine x, the derivative is cos x. That means if my function is cos x, the integral is sine x plus the constant. If my original function is cos x, the derivative is negative sine x, which means if my original function is negative sine x, my integral will be cos x plus a constant. Tan x to sec squared x, backwards sec squared x, integral gives you tan x plus a constant. Cosec x is negative cosec x times cos x. Go the other way around, if that's my original function, that's my integral. If that's my function, sec x, my derivative is sec x times tan x. If sec x times tan x is my original function, the integral is sec x plus a constant. If the original function is cot x, the derivative is negative cosec squared x. If the original function is negative cosec squared x, the integral is cot x plus a constant. We'll keep on referring back to this table. Even though it's given to you, it's a good idea to learn it because it just makes you more efficient, makes you faster in a test or an exam. Okay, so let's have a look at this first example here. Right, I need to find the integral of cos x dx. So I look at my table, I see if I can find that. Yes, there it is, cos x. What is the integral? It is simply sine x. So, put that in, the integral of cos x is simply sine x plus my constant of integration. Check, if I differentiate sine x, I'm going to get cos x. Cool. Let's look at another example. If I've got the integral of sine x, I go back to my table and I see if I can find sine x. I look here and I can't find sine x, but I can find negative sine x. So what we do is we make this one look like negative sine x. So I want the integral of negative sine x. And mathematically, I'm allowed to introduce that negative as long as I times it by another negative, inside or outside. Now it's quite easy, that negative sits outside. The integral of negative sine x is simply cos x plus my constant of integration. Bearing in mind that negative is that negative, just sits outside, and the integral of negative sine x is cos x. If we go backwards to check, if I want to differentiate cos x, I'm going to get negative sine x. That minus just sits there, minus and a minus is a plus. Okay, so what we actually did here, and what's very important to remember, is we created. So it's almost like we create negative sine x. And you're allowed to do that as long as you can follow through with a mathematically legit move. In this case, was multiplying by negative sine x. Let's look at this next example. Example 3. What's the integral of sec squared x? Well, let's see if I can find it. There it is, sec squared x. So the integral of sec squared x is tan x. Okay, so the integral of sec squared x is just tan x. Awesome. Alright, let's have a look at the next one. I'm looking for the integral of cosec squared x, so I go back to my table and I look for cosec squared x. I can't find cosec squared x, but I can find negative cosec squared x. So I can create that. Let's do that. So I actually want the integral of negative cosec squared x I can introduce that negative as long as I multiply it by a minus. The integral of negative cos x squared x, let's go back and just double check, is cot x. So here's my negative from the outside, and I've got cot x plus my constant of integration.